Hi folks, we're going to take a look at number 19 from page 234. All right, so let's see what they're asking us to do. So they're talking about this angle 2x, and they tell us that 2x lies in the fourth quadrant, and that cos of 2x is 8/17. Not surprising that it's positive since 2x is in the fourth quadrant and cos is positive there. So I'm going to start by drawing myself a diagram to get a sense of where this angle is. Okay, so there we go. We can call that the angle 2x somewhere in the fourth quadrant. All right, so there we go. We've got part A already done. Sketch the angle 2x. All right, now the interesting part is B, which quadrant contains angle x? All right, so I don't know exactly where 2x is, but I know it's at least an angle of 3 pi over 2 and at most an angle of 2 pi. So if I want to figure out where x is equal to, well, it can't be further than half of 2 pi, and it has to be at least half of 3 pi over 2. Since this is the maximum possible value of 2x, the maximum possible value for x will be half of this, and the minimum possible value for x will be half of 3 pi over 2. So if we wanted to draw where angle x was, let's figure out. Well, we know it needs to be at the very most half of 2 pi, which of course is pi, and at the very least half of 3 pi over 2, which is 3 pi over 4. Okay? So in fact, not only were we able to say that it's in the second quadrant, we can actually say that it's somewhere in this area here. Okay? So how did we get the 3 pi over 4? Well, it's half of 3 pi over 2. Okay, and how did we get the pi? Well, that's just half of 2 pi. Okay, so we know that the angle x is somewhere in 3 pi over 4 to pi. Okay, so in fact, we were able to be even more precise than what the textbook was giving us. So therefore, x is in quadrant 2. Now, I suspect we need to know this because the sign of the trig ratios are going to come into play. So knowing what quadrant it's in is going to help us. All right, so let's go to C. It says determine the exact value for cos x. All right. Problem is the information we're given has to do with cos of 2x. We know that cos of 2x is equal to 8/17. So what we need to do is to find a way to relate cos 2x to cos of just x. And we've actually found a way to do that because we have one of our double angle formulas. Okay, remember that we've got 3 double angle formulas for cos 2x. We have that cos 2x can be written as cos squared x minus sine squared x. I don't think this is going to be useful. Okay, cos 2x can also be written as 1 minus 2 sine squared x. I don't think this is going to be useful either because I'm looking for cos x, not sine x. But of course, there's the third one, 2 cos squared x minus 1. And what's nice about this one here is I can rewrite cos 2x as an expression that contains cos x. All right, so let's just do that. I'm just going to replace cos 2x by 2 cos squared x minus 1. Okay, something perfectly legal to do since we established this identity. All right, and now I'm just going to solve for cos x. So 2 cos squared x is equal to 8/17, and this is going to be plus 1, so plus 17/17. Okay, and then I'm going to divide by 2, so cos squared x is going to be equal to, well, 8 plus 17 is 25/17, but of course I'm also dividing by 2. So 17 times 2 is 34. Okay. Now, this is where you have to be careful because in order to solve for cos x, I have to take both the positive and negative square root because I'm taking a square root. And I know when I solve an equation, I have to be careful to take both the positive and negative square root. So the question is, which one of these is the answer? And I think this is why now we're seeing they asked us to answer part B. Okay, I'll just give you a heads up that likely I won't ask this specifically if I'm giving you a similar problem on a test. I would expect you to know once you got to this place here that you have to figure out what quadrant x is in. But we already established that x was in quadrant 2, so that means cosine has to be negative. So cos x is negative root 25/34. We can clean that up a little because root of 25 is 5. So negative 5 over square root of 34. Okay, and why do we know it's the negative 1? Since x is in quadrant 2. All right. So very nice problem here because it allowed us to work with our knowledge of the quadrants, but also, first time we're really seeing having to use one of these double angle formulas that we established. All right, so let's finish off by looking at D and E. So it says use a calculator to determine the measure of x in radians. Okay, so notice we did everything exactly, but I know that, so let's put D here, I know that cos 2x is equal to 8 over 17. So if I want to find some approximations, I can just use my calculator. Okay, so this is where we have to be careful because 2x, if I just take cos inverse of 8 over 17, okay, let's get a calculator here and see what that brings to us. So always make sure your calculator's in radians. So here we have cos inverse of 8 divided by 17 is equal to, and what the calculator gives us is 1.08. Okay. There's a problem though. Remember what they told us, sorry, this is what 2x is equal to. Remember what they told us, 2x should be in the fourth quadrant, but 1.08 is an angle in the first quadrant. But of course we know that there's lots of angles that have a trig ratio of 8 over 17. So this is where we have to do a little bit of interpretation. The answer the calculator gives us, calculator can only give us one answer for 2x, is 1.08. But we know that this is going to be in the fourth quadrant. And what angle has the same cosine value as an angle in the first quadrant? Well, we know that that's equal to 2 pi minus our angle theta. So in this case here, I'll approximate. So 2 pi is about 6.28 minus 1.08. All right. And, we should be able to do that in our heads, but let's just be sure. 6.28 minus 1.08. So it means that 2x is actually equal to, what was that? 5.2. So some interpretation to be done here. And so that means x is going to be half of that. Well, that should be 2.6 divided by 2. And there you go, 2.6, which, by the way, is an angle in the second quadrant, as we expected. Now, it says check your answer. Okay, how can we use this to check our answer? Well, remember what we found in C. We found that cos x was negative 5 over root 34. So let's check here. If I take cos of 2.6, let's see what we get approximately. So here, cos of 2.6 is equal to negative 0.857. Negative 0.857, and let's check that with the answer we got. And negative 5 over square root of 34 is approximately equal to, hopefully, if we did this right, the same number, square root of 34. And look at that, negative 0.857. Now, obviously, these were both approximations, but definitely close enough to assume that they're the same. All right. So a lot of things going on in this problem. Now, this, like I said, they really led you through every part of this question. Chances are the only thing you're going to get is, given that cos 2x is equal to 8 over 17, determine an exact value for cos x. That's likely what you would be getting as a question on a test. But let's see what we first did. Step number 1 is use the fact that 2x was in the fourth quadrant. We were then able to determine what quadrant x needed to be in. Why was that important? So that when we solved for cos x using the correct double angle formula, I was able to choose the correct root, whether the positive or negative. You can imagine something similar would be happening if you were solving for a sine value. All right, that's it for this one.